All right, in this video, we're looking at right triangles and we're finding angle measures. Here's an example right here. In this triangle, we know that this side right here is 12. We know that this side is 15. We want to figure out what this angle is, theta. Well, now if you label your sides, here's my right angle, which means here's my hypotenuse. And with this angle I'm going to deal with, my opposite would be way over here. And this 12 is my adjacent. So the hypotenuse is 15, the adjacent is 12. The opposite, we're not really concerned about it because there's no information there. So that means it sets up like this. This is hypotenuse and adjacent. If you remember your ratios, this is cosine, adjacent over hypotenuse. So I would set this up, cosine theta equals the adjacent 12 over 15. That's how this sets up. So we know the adjacent, we know the hypotenuse, we just don't know the angle. All right, now to do this, you have to do what's called the inverse cosine. So what I'll do is, my pen quit on me. I'm going to do what's called the inverse cosine, or the cosine inverse of both sides. When I do the cosine inverse of the cosine, these will just cancel off and I have theta. So theta is going to be cosine inverse of 12 over 15. And this is real simple to do. If you look at your calculator, see here's cosine right there. And if you notice in the blue right above it, there's cosine inverse. If I hit the second button and then hit that button, well, let's turn it on first. If I hit the second button, then I hit the cosine button, you see cosine inverse comes on there. And so all I do is I do 12 divided by 15. And there you go. It's a 36.86 degree angle. If you round it to the nearest tenth, which I think is what we're doing here, 36.9. So that tells us this angle right here is 36.9 degrees, which is very helpful. Like, suppose you're cutting boards here to make this triangle. What angle do you cut your board at to make it go this direction like you need it to be? Well, it needs to be a 36.9 degree angle. So this is very useful. All right, let's look at some problems here. We'll do a few of these. We want to figure out what theta is right there, and we see the answer right here, 26.7. All right, well, how do you get that? Well, let's label our sides first. So here's the right angle, which means over here's my hypotenuse. And for that angle, here's opposite, and this is adjacent. So there's my sides labeled. Okay, in this problem, I'm not concerned at all about the hypotenuse. I've got the opposite and the adjacent here. Okay, which means we're looking at tangent, opposite over adjacent. So to set this up, this is going to be a tangent of theta. We don't know the angle, but we do know the opposite, which is 8, and we know the adjacent, which is 15.9. So there's how you set it up. So to solve this, then all we got to do is tangent inverse. All right, so here's tangent, and you can see tangent inverse right there in the blue. So I hit second, tangent inverse, and it comes on there, tangent inverse. And I just type in, what was it? 8 divided by 15.9. And there it is, 26.7, just like we were told it was. Okay. Now on this one, let's do it same way. All right, let's label our sides. So here's the right angle, which means here's my hypotenuse. Here's theta, the angle I want to find. So that means over here is my opposite. And here's my adjacent. And the one side I don't care about here is my hypotenuse. So I've got opposite and adjacent, which is tan again. We got another tan one. Tan theta equals my opposite, 15.6 over my adjacent, which is 16. All right, so to solve this, I'm going to do tangent inverse. So do inverse tangent, 15.6 divided by 16. and I get 44.27, which is 7 makes the 2 go up to the 3. So 44.3. Okay. Here's another one. Okay. Man, are all these tangent? This is another tangent one. I want to do one that's different. Let's see here. Man, the first 5 are all tangent. Here's one that's not a tangent one. So I label my sides. Here's my right angle, which means here's my hypotenuse way over here. Here's my theta, which means there's my opposite. And right here's my adjacent. All right, in this one, I don't care about the adjacent. It's the opposite and the hypotenuse is what I have. All right, so that tells me right there that's sine. Opposite and hypotenuse. That's a sine. So I'm going to set it up like this. Sine theta equals the opposite, which is 7, over the hypotenuse, which is 12. That's how I set it up. Okay. And so now I do inverse sine. Okay, so second sine, which is inverse sine. You see it on there? Okay. 7 divided by 12. And that comes out to 35.68, which the 8 makes the 6 go up to 7. 35.7, so we're good. We got it. Okay, here's one. All right, well, that's another tangent one. Man alive, how many tangent ones they got on here? All right, so here's my right angle, which means here's my hypotenuse. And so for this, there's my opposite, and here's my adjacent. So opposite and adjacent, the hypotenuse I don't care about, which is tangent again. So I'm going to do tangent theta equals the opposite, which is 7, over the adjacent, which is also 7. So I'm going to do tangent inverse. So inverse tangent, and it's 7 divided by 7, which is 45. So theta is 45. You can see my angle right there. It's at 45. Okay. How about this one? All right, so here's my right angle, which means here's my hypotenuse right there. For theta, this is the opposite, which means this is my adjacent right here. Okay. So I don't care about the adjacent here. So this is the opposite and hypotenuse, and that's sine again. So this is sine theta equals the opposite, which is 4, over the hypotenuse, which is 12. All right, so I want to figure out what theta is, so I'm going to do inverse sine. So see, I would do inverse sine of both sides, which makes this cancel. So theta equals inverse sine of 4 over 12. So I'm just going to do inverse sine 4 divided by 12, which is 19.47. The 7 makes the 4 go up to a 5. 19.5. Okay. Well, let me make up one or two, because the rest of these, I didn't realize there's so many dang tangent ones on here. So let's make up one here. Here's a right triangle right there. Okay, let's figure out what theta is here. And on this one, this is 16, and let's say this over here is 11. Okay, what's my theta? All right, so the first thing we do is label the sides. So here's my right angle, which means here's my hypotenuse right there. There's my theta, so over here's the opposite, and this would be adjacent. Now, which of the 3 sides do we not care about here? We don't care nothing at all about the opposite, because there's nothing there. I've got the hypotenuse and the adjacent, and right there, it's cosine. This is a cosine problem, so I'm going to do cosine theta equals the adjacent over the hypotenuse, 11 over 16. So there's how you set it up. Oops. Okay, which means I'm going to do cosine inverse of both sides, which makes this cancel, and theta equals, cosine inverse of 11 over 16. Okay, I don't know why I started right at S there. inverse cosine 11 divided by 16. And that's 46.6. So this angle is 46.6. Okay, I'll make up one more. Let's say I got this triangle right here. Okay. Let's say we want to figure out what this angle is. There's my theta. All right. And let's say this is 14, and let's say this is 17. What's theta here? All right, so you label your sides. There's my right angle, which means here's my hypotenuse. Here's my theta, which means over there is the opposite, and here's adjacent, right next to my theta. Which one do I not care about? I don't care about the adjacent this time. There's no information there. I got the opposite and the hypotenuse, and if you look at your trig ratios, that's going to be sine. So this is another sine. So sine theta equals the opposite 14 over the hypotenuse 17. That's how you set it up. So now I'm going to do sine inverse. Sine inverse of both sides. So sine inverse of 14 over 17. This is what I punch in. So sine 14 over 17. And oops. 55.4. So this is a 55.4 degree angle right there. So that allows us to construct this triangle, or that now that we know that angle, whatever reason we need the angle, that'll help us. All right, so like here's a problem where we need to figure out what this angle is. And we see Chelsea here. She's walking up a road that has a 30% grade. She's going to her favorite store. At what angle is the road inclined? What's this angle right here? So you see the theta there. So let's just redraw it. Here's my triangle again, and this is theta, the angle we're looking for. Now if it's got a 30% grade, that means it's going up 30 for each 100 it goes over. That's 30%. So that means this is 30 right here, and this is 100 down at the bottom. And of course, that's a right triangle. Okay, so what's this angle here? All right, so we label our sides. So here's the right angle, which means here's my hypotenuse right here. There's my theta, which means over here is opposite, and this is adjacent. All right, which of the three sides do I not care about? The hypotenuse. So I got the adjacent and the opposite, and this is a tangent. Tangent theta equals the opposite 30 over the adjacent, which is 100. So I'm going to do, to solve this, I'm going to do tangent inverse, which makes this cancel. So theta equals, see, when I do tangent inverse of tangent, those cancel. So I'm going to do tangent inverse of 30 over 100. So tangent inverse 30 divided by 100, and that's 16.7. So this angle right here is 16.7 degrees, and that's what the angle is. Okay. One more here. Here's a hot air balloon. It hovers 85 feet above the ground right here. The balloon is tethered to the ground with a rope that's 125 feet long. So this rope here is 125 feet long. You can see it's at an angle. It's not going straight up, so it's only 85 feet above the ground here. At what angle of elevation is the rope attached to the ground? So we want to figure out what this angle is right here. Well, let's draw it over. Here's my triangle. We want to figure out this angle. This is 85, and this is 125. And of course, this is a right angle here. So there's my triangle. Now label the sides. So here's my right angle, which means this is my hypotenuse. Here's my theta I'm looking for, which means this is my opposite over here. And down here's the adjacent. Now, which of these three sides do we not care about? Right there, adjacent. There's nothing here. I got the opposite and the hypotenuse. And if you look at this, that's sine, opposite hypotenuse. That's sine. So this is a sine theta equals the opposite 85 over the hypotenuse, which is 125. So there's how it sets up. So to solve this, I got to do sine inverse, both sides. These cancel. Theta equals sine inverse of 85 over 125. So punch in again. Inverse sine 85 divided by 125. And there you go, 42.8. So this is a 42.8 degree angle. That's what the angle of elevation is for this balloon. Okay. So I think that's it. That's how you find angle measures in right triangles. You try this assignment. If you need any help, give me a holler. I'll help you all I can. So have a good rest of the day. Bye-bye.